This is section 6.3, which talks about radians. And if you look in the picture on the upper right-hand side here, radians are a different way of measuring angles. Up to this point, we only know how to measure them in degrees. Well, now we're going to learn how to do them in radians. And when you measure an angle with arc length, and if you look over here in the picture, that's exactly what it does. It's talking about the length of the circle on the circumference. Then it talks about radians. So what we can say then is that 1 radian is defined to be an angle, of course, in a counterclockwise direction, as we've been doing, from the terminal side to which it has an arc length of 1. 1 unit of arc length. And what that means is, take a look back over here in this picture. If I have this piece right here, let's say this red piece, go like this, and this happens to be 1 radian, okay, and let's say that the circumference of this circle was measured in inches. Then I could say that 1 unit of arc length is 1 inch long. So from the terminal side to the end of that radian is equal to 1 inch. So that's what the definition of a radian is. And it's actually very, very helpful later on in pre-cal and in calculus. And even in upper mathematics, they really start to move away from degrees and start using radians. So why do we use it? We use it because it's more helpful in upper mathematics. So it's just more useful in the world of math. So that's the general idea behind radians. And what's nice to know about it is if we have a degree, we can convert it into radians and vice versa. So I'm going to show you how to do that. There is a little formula that's on your Moodle page, which basically says if I have 1 radian, it is equal to 360 degrees, which is a full entire circle, divided by 2 pi. And why 2 pi, do you ask? Well, if you remember, or I'm going to write over here to the side, the circumference of a circle, remember that radians talks about arc length. The circumference of any circle is equal to 2 pi r. Okay? So if r was equal to 1, if we were dealing with our unit circle, then the circumference would just be 2 pi. So what I'm trying to do here in this formula is I'm going to take a full entire circle, 360 degrees, and divide it by however much of my circle that I have. So it's going to be really, really helpful for us to use a couple different formulas, and I'm going to write them down, and we're going to work out some problems together. All right, so this is what we're going to do. So if I want to convert radians to degrees, the way that I'm going to do it is I'm going to take the amount of radians that I have, and it can be a decimal, it can be a fraction, it can be a whole number, it doesn't matter. And I'm going to multiply it by this 360 degrees over 2 pi. Or I can simplify that to 180 over 1 pi, since 360 and 2 pi have 2 as a common factor. So I'm going to just show you that instead because it's just more common. So 180 degrees over pi. So that's the simplified version of this. Okay? So, for example, if I want to convert 2 radians, and unfortunately there's no shorthand for radians, so we're going to have to write them out. And I'm going to multiply it by 180 degrees, and then I'm going to divide that product by pi. So 2 times 180 degrees is going to be 360 degrees, and that's going to be over pi. And in my calculator, I'm going to go ahead and simplify that. I'm just going to do some division and get a decimal. 360 divided by pi, and do not use 3.14. Use the pi button on your calculator. And that's going to give me 114.592 degrees. So that's how I convert radians into degrees. So how do I go the other way around? Well, it's just the exact opposite. I'm going to take the degree measure that I have, so degree measure, and I'm going to multiply that by the radians that I have with pi, and I'm going to divide that by 180 degrees. So it's just the opposite. So let's say I want to convert 60 degrees into radians. I'm going to take that, I'm going to multiply that by pi, since radians are measured in pi, and I'm going to divide it by 180 degrees. Do not, if you can, if this comes out to be a nice fraction, leave it as a fraction. You'll see why later, but 60 divided by 180 reduces to 1/3. So that 3 is going to go in the denominator. 1 is understood to be in the numerator, and it's being multiplied by pi, so this is pi over 3. And this is a lot nicer of a way to write this answer because it's just far more simplified. If you can write an answer without a decimal, that's what you want to do. So that's your overview of 6.3.